All right, today in geometry, we are looking at section 4.2, applying congruents and triangles. We're going to start out with a lot of vocabulary. First, a figure is a set of points in a closed plane or space. So this is a set of points. A figure can be two-dimensional if it is in a plane, and three-dimensional if it is in space. Two figures are said to be similar if they have same shape, but not the same size. So similar, they have the same shape, but not the same size. The corresponding angles of the two similar figures are equal. The corresponding sides have the same ratio. The two figures shown below are, these are similar because they have the same shape. They're both rectangles, but they're not the same size. The corresponding angles, so all of the angles that sit in the same spot, remember corresponding means sit in the same spot, are equal. The corresponding sides have the same ratio. So this side to this side, 2 to 4, or 1 to 2. This one to this one, 3 to 6, 1 to 2. Or if we had gone the other way, the big triangle first, it would have been 4 to 2, which is 2 to 1. And so that's what we've done here. The sides, right, of two triangles have a ratio of 2 to 1. Okay? Therefore, I could say that the triangles are similar. They have the same ratio of the sides, and then they are similar. Two figures are said to be congruent if they have the same shape and the same size. So that's the difference between congruence and similar. Similar, they have the same shape, but not the same size. Congruent, they have the same shape and the same size. The corresponding angles of two congruent figures are congruent or equal. The corresponding sides are congruent, again, slash equal if we're talking about measures. The two figures shown below are, so we need to decide, are they congruent or are they similar? I see the sides, they all have the same tick marks, so I know that all of my sides are congruent. So sides are congruent. All of the angles in the first one are 108 degrees. All of the angles in the second one are 108 degrees. So I know that all of my angles are congruent. I have 1, 2, 3, 4, 5 sides. So I have a, pentagon. 1, 2, 3, 4, 5, another pentagon. So they're the same size, they're the same shape, all the sides are congruent, all the angles are congruent. So the two figures shown below are congruent. All right, it tells me the sides of two rectangles have a ratio of 1 to 1. Therefore, the rectangles are, notice that they have a ratio of 1 to 1, the numbers are the same, so they're not similar, they are congruent because they have the same sides. All right, on the back, congruent triangles. Two triangles are congruent if they have exactly the same size and the same shape. This means that one figure can be slid, turned, and or flipped so that it fits exactly on the other figure. Recall the symbol for congruence, so our equal sign with a little squiggly line on top. When two figures are congruent, we always list corresponding labels in the same order. So in the figure below, it is proper to say triangle ABC is congruent to triangle DEF, but it would be incorrect to say triangle ABC is congruent to triangle DFE. Okay? We can show corresponding parts easily with arrows. Okay? So they have to be in the same spot. So A and D, okay, they both would have to be in the same first spot. B and E, both in the second spot. C and F, third spot. right? So if I'm given the statement like this, okay, I know what corresponds to angle D. Well, what's in the same spot as D? A, so angle A. I'm looking at the picture. What corresponds to angle E? This is my angle E here, so right here, angle B. What corresponds to angle F? Okay, what sits in the same spot? So angle F is angle C. Side AC corresponds to, so if I'm looking at the picture, side AC would correspond to side DF. If I'm just looking at the statement here, side BC, so BC is the middle and the last, so it corresponds to, in my statement, the middle and the last, EF, side EF. And finally, side AB corresponds to side DE. Remember, corresponding means sits in the same spot. All right, this is extremely important. CPCTC. Two triangles are congruent if and only if the corresponding parts are congruent. Okay, so CPCTC. This stands for corresponding parts of congruent triangles are congruent. You need to know that. Memorize that. CPCTC, corresponding parts of congruent triangles are congruent. When writing a congruent statement, we always list the corresponding vertices in the exact same order. Okay? All right, so now we're going to look at some more theorems. Theorem 4.3 is called the third angles theorem. This tells me if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. That makes sense, right? Common sense. So let's mark here A and D the same, and then we'll mark B and E the same. So I could say if angle A is congruent to angle D, and angle B is congruent to angle E, then I could say angle C is congruent to angle F. That's what that theorem tells us. Okay? Next theorem, 4.4, properties of congruent triangles. So we have the reflexive property of congruent triangles. So this just tells me for any triangle ABC, the triangle ABC is congruent to triangle ABC. So remember, reflexive, you have the exact same thing on both sides. Right? It's the exact same order. Symmetric property of congruent triangles. So remember, we've done all of these properties before, but now we're specifically relating them to congruent triangles. Symmetric property of congruent triangles tells me if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So remember, the symmetric properties where they just trade places, right? So the ABC and the DEF just traded places. Transitive property of congruent triangles. Remember, this is like our chain rule. So this tells me if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then the very first triangle ABC is congruent to the very last triangle JKL. All right, so in the diagram, BEFG is congruent to SPQR. Find the value of X. Okay? So I look and see X is with QR and angle Q, right? So I look at side QR, and I need to know what does that correspond to. So QR has to be congruent to, okay? So QR, they're the last two, so it has to be congruent to FG. So it has to be congruent to side FG. So in my picture, side FG, down here is 12, okay? So part A, to find X, I would say 2X minus 4 equals 12. Now I want to solve that to get the X all by itself, so add 4. So I get 2X equals 16, divided by 2, X equals 8. So there's part A, X was equal to 8. Now part B, find the value of y. So y is with angle Q. So angle Q has to be congruent to, so Q is in the third spot, angle F. So angle F is 68 degrees. So I would say 6y plus, instead of x, I now know x is 8, equals 68. Get y by itself, so 6y equals 60. Divide by 6, y equals 10. So that's how we're using the corresponding parts. Okay? Right? On the back, find the measure of angle BDC. Okay? So angle BDC, this angle in here, and if it helps, we can draw these separate. So let's take these triangles and draw them out. So this is A, C, D, and this is B, D, C. Okay? So I know that B and A are the same, and they tell me it's 45 and 45. Okay? Let's see, angle D I know is 30 degrees here. And the measure of angle BDC. So BD to C. This is marked 2 tick marks. 2 tick marks is the 30. In this triangle, it was marked 2 tick marks, so I know that's 30. So this is the angle I'm looking for, angle BDC. Okay? So the measure of angle BDC equals 180 minus 30 minus 45, right? Because they all have to add together to equal 180. So 180 minus 75, which equals 105 degrees. So the measure of angle BDC equals 105 degrees. So I separated those triangles out and then used corresponding parts and the markings to label what I knew. All right, so let's try that. This next one, find x and y. So these are the two pictures that they give to me. They tell me that ABCD is congruent to EFGH. Okay, so if I look at x, x is angle F. Angle F, second spot, B, second spot. So I know that F and B are congruent to each other. So I would set this up and say 10x plus 65 equals 135. Subtract 65 from both sides, so then I get 10x equals 70, divide by 10, x equals 7. So there's my first one. Y is angle E. Angle E is in the first spot, A is in the first spot. So I know that angle A congruent to angle E, and I knew that angle B was congruent to angle F. So E, 4y minus 4 equals 28. There's my next equation. Add 4 to both sides, so I get 4y equals 32, divide y equals 8. Okay. Find the measure of angle 1. Okay. I see L and Z are the same, N and Y are the same. So then that third angle theorem tells me that M and X have to be the same. Since I have a 90-degree angle, then I know that these two have to add together to equal 90. So I could say the measure of angle 1 plus 70 has to equal 90. So the measure of angle 1 equals 90 minus 70, 20 degrees. The second one, I've got 2 tick marks here, 2 tick marks here, so I know this is 45. 1 tick mark, 1 tick mark, I know this is 80. Again, the third angle theorem, this is would have to be angle 1. I know all 3 angles have to add up to equal 180, so measure of angle 1 plus 45 plus 80 equals 180. So the measure of angle 1, so add together 80 and 45, and I get 125 equals 180. So now I need to subtract that from 180. So then I get the measure of angle 1 is 55 degrees. Okay. All right, let's keep going. Lots of notes today. So this is the picture that they give to me, and they ask me which angle is congruent. Okay, so angle J is congruent to, so angle J has 2 tick marks. So in this picture, the angle that has 2 tick marks, angle T. Angle K is congruent to, K has 3 tick marks, S has 3 tick marks, angle S. Angle L is congruent to, L has 1 tick mark, angle R, 1 mark. Which sides are congruent? So JK, again, it has 1 mark, okay, is congruent to, so ST, but I have to put it in the right order. So the angle had 2, so I need to go from 2 to 3. So that's going to be side TS. KL, so 2 tick marks, K and S, but I want to start with the one that has the 3 marks at the angle, so side SR. Side JL has 3 tick marks, so I know I'm looking at RT, but J, I'm starting with the angle of 2 marks, so I'm starting with T, so side TR. We always have to make sure that they are corresponding, sitting in the exact same spots. Write a congruent statement. Okay, so I could say triangle JKL. Doesn't matter the very first one I start out with. Triangle JKL is congruent to triangle. So J and T are in the same spot, right? Because they both have the same marks. So triangle TSR, the way that I wrote mine. Identify all pairs of congruent corresponding parts, then write another congruent statement. So identify all pairs, so that means I need all the angles and all the sides. So I'll start with angle A, congruent to, so I have 3 tick marks. Over here, angle D has 3 tick marks. And I'll go angle B is congruent to, so 2, angle E has 2 tick marks. Angle C, congruent to angle F. So those are half of my corresponding congruent parts. So now I need to do all of the sides. So again, I'll start with A to B, so side AB, congruent to, so I went from 3 to 2, so that's going to be side DE over here, 3 to 2. Then I could say side AC is congruent, so 3 to 1, it's going to take me 3 to 1 over here, D to F. And then finally, I could say side BC, actually let me just scroll down. Side BC is congruent. I went from 2 marks to 1 mark to side EF. And then write another congruent statement. So they gave me triangle ABC congruent to triangle DEF. So I could say triangle CAB is congruent to triangle. So instead of the C, I would need F. Instead of the A, I would need D. Instead of B, E. Okay. All right. Let's try some more of those. So here we have this picture. It says complete each congruent statement. So this is the picture that they give me. Okay. I see H and K both have 2 marks on them. I have a side marked 12 in both triangles and a side marked 10 and 6 in both triangles. So triangle HGI, so H to G, okay, that's going from 2 marks down to 1 mark. So 2 marks down to 1 mark is K to L, so KLJ. Okay. Triangle JKL, so J to K, so 3 to 2. Another triangle, 3 to 2 is IHG. So the order is extremely important here. They have to match up. IGH, so I to G, so 3 marks to 1 mark. So 3 marks to 1 mark. Triangle JLK. Triangle LJK, so LJ, so 1 to 3. So over here, 1 to 3 is GJH. Okay? Oh, sorry, that's an I. It's an I. GIH. So remember, when we are talking about congruent statements, order is extremely important. It matters. Let's try this one. So I have triangle ATM and triangle KEV. Okay. So it says triangle ATM is congruent to, so A, to T, I go from 2 marks to 1 mark. So in the other triangle, 2 marks to 1 mark is going to be EKV. EKV. They already have the triangle notation drawn for me. If they had not, I would have to write that as well, okay? So, and again, that is a V, EKV. Triangle TMA, so TMA, so 1, 3, 2. So 1, 3, 2, KVE, triangle KVE. Triangle MAT, M-A-T, so 3 to 2, down here, 3 to 2, triangle VEK. And finally, triangle TAM, 1 to 2, so 1 to 2, KEV, triangle KEV. So that's all about congruent statements and corresponding parts, okay? Our homework today is a worksheet 4.2. Right? You can find that in the announcement. Tomorrow we will look at some more theorems with our triangles and do a little discovery lab.